Hello, 7th graders. This is Miss White, and today we're doing Lesson 10, Conducting a Stimulation to Estimate the Probability of an Event. So in the previous lessons, we have estimated probabilities of events by collecting data empirically or by establishing a theoretical probability model. There are real problems for which those methods may be difficult or not practical to use. Stimulation is a procedure that will allow you to answer questions about real problems by running experiments that closely resemble the real situation. It is often important to know that the probabilities of real-life events may not have known theoretical probabilities. Scientists, engineers, and mathematicians like you design and stimulate to answer questions that involve topics such as disease, water flow, climate change, or functions of an engine, which really you guys are learning how to do those things, but just at a much more basic level. Results from the stimulations are used to estimate probabilities that help researchers understand problems and provide possible solutions to these problems. So let's look at example 1. How likely is it that a family with 3 children has all boys or all girls? Let's assume that a child is equally likely to be a boy or girl. Instead of observing the result of the actual birth, toss a coin, or a fair coin, that could be used to stimulate a birth. If the toss results in heads, then we can say a boy was born. And if the toss results in tails, then we could say a girl is born. If the coin is fair, that means that both heads and tails are both likely, then getting a boy or a girl is equally likely. All right, so for exercise 1, it says suppose that a family has 3 children. To stimulate the genders of the 3 children, the coin or number cube or a card would need to be used 3 times, 1 for each child. We are just going to go ahead and just use a coin to help us with the probabilities of what each of these 3 children are going to be, whether they're a boy or for a girl. For example, 3 tosses of a coin result in HHT. Representing a family with 2 boys and 1 girl, note that HTH and THH also represent the 2 boys and 1 girl. So suppose that when a prime number is rolled on a number cube, which is a dice, okay, number cube is the same thing as a dice, it stimulates a boy birth, and a non-prime number stimulates a girl birth. So using such a number cube lists the outcomes that would likely stimulate a boy birth and those that would stimulate a girl birth. Are the boy and girl birth outcomes equally likely? All right, so what I'm going to do is I'm going to draw So what I'm going to do is I'm going to draw 6 sides of a dice here. So what I'm going to do is I'm going to draw 6 sides of a dice here. You can go ahead and do that with yours as well. Obviously, my squares are not going to be perfect, but that's all right. Okay, so for a dice, we have our one side, which has 1 dot, second side that has 2 dots, third side has 3, fourth side has 4, fifth side has 5, and then the 6th side has 6. Okay, now here's what we need to do. We need to label whether or not they are prime numbers or non-prime numbers. So 1 is a non-prime, 2 is a prime, 3 is a prime, 4 is a non-prime, 5 is a prime, and 6 is a non-prime. Now, by drawing our dice, are the boy and girl birth outcomes equally likely? Yeah, they are, because we have an outcome of 3 out of 6 sides for the girls and 3 out of 6 sides for the boys. All right, let's go ahead and flip our page to example 2. So stimulation provides an estimate for the probability that a family of 3 children would have 3 boys or 3 girls by performing 3 tosses of a fair coin many times. Each sequence of 3 tosses is called a trial. If a trial results in either heads, 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 or tails, 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 then the trial represents that all boys or all girls, which is the event that we are interested in. These trials would be called a success. If a trial results in any other order of heads or tails, then it is called a failure. So the estimate for the probability that a family either has 3 boys or 3 girls based on the stimulation is a number of successes divided by the number of trials. Suppose 100 trials are performed, and in those 100 trials, 28 resulted in either heads, 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 or tails, tails, tails. Then estimated the probability that that family of 3 children has either 3 boys or 3 girls would be 28 over 100, or in decimal form, 28 hundredths. Now this is telling me out of 100%, which would represent all of our trials, that only 28% would either be all boys or all girls. So to find the percentage that it wouldn't be all boys or all girls, we would take our 100% of our trials minus the 28 over 100, which can be represented in what percent? 28% of the trials that show up that we're either going to have all boys or all girls, and that's going to give us 72%. Now, another way that we could have looked at this is we could have done this even in decimal form. So 100 in decimal form is going to give us 1, minus 28% in decimal form is going to give us 28 hundredths, equals 72 hundredths, which we know in percent form is going to give us 72%. All right, and that concludes our lesson for today. I will see you in class.